Okay, so in the previous video, we introduced explicit and implicit equations. Okay, now, obviously this is where implicit becomes a problem, because we have a function that has x in it, what also has y terms in there as well. Now, this is something similar to what you look at university, which is partial differentiation, but implicit differentiation is the cheat way around it that we use at A-level. So, if we wanted to differentiate, if something like, I don't know, just y on its own, well, what happens when you just differentiate y? Well, you get y prime, which is, dy by dx, which we use all the time, don't we? So, what if happens if you differentiated things like y squared? Well, to differentiate y squared, I'd have to use the product rule on that, because I do not have a way of differentiating just y squared yet. So I'd have to say, well, that's taking the derivative then of y times y, which then allows me to use the product rule. So I have the first times the derivative of the second, plus the second times the derivative of the first, which is 2y dy by dx. And then you'll be able to spot the pattern now. Because if I did the same again, I'll go ahead and do y cubed for you. Because what happens if you do y cubed, or y to the 4, the pattern's going to be, differentiate that, 3y squared, dy by dx. Try it. Try y squared times y. Differentiate it using the product rule, see what happens. Because we know what the previous result is for y squared. Try it out, see what you get. So let's think about what we get when we take the derivative of e to the y then. So not just standard polynomials going into e, the e world. Now, when we differentiate e, we get the self, right? But we also, because of the chain rule, we have to differentiate the y as well. Well, in order to y is dy by dx. So it's just the function times dy by dx. Nothing special, and it's not exactly nice, but it works in the same principle. Look at differentiating y to the 4, for example. Y to the 4 is 4y cubed dy by dx, or y dash. Okay? So, when we're differentiating, in general, just a function of y in respect to x, all we're going to get is the derivative of the function of y times dy by dx. That's all we're doing here, which is the fundamentals of implicit differentiation, which we're going to look at in the next video. We'll look at some examples.